Hello everyone, I welcome you all for this live session. In this live session, we are going to discuss the key solutions for the written examination conducted by ISRO for the recruitment of scientist C cadre jobs in the ISRO. So this ISRO examination for the scientist C cadre was held today. Today means the 7th January 2024 in different branches of engineering. In this session, we are going to cover the civil engineering paper, the solutions and the brief discussion about each question. Before I go into this discussion of the key, first of all, let me give you the weightage that was given in this ISRO examination today in different subjects of civil engineering. Let me show the slide. You can see here the various subjects along with the number of questions that were given in this ISRO examination for the scientist C cadre jobs. So as you see here, like in any other exam, in this ISRO examination also, the geotechnical engineering commands the highest weightage of 13 questions, right? You know, totally we have 95 questions. Out of 95, 13 questions from the geotechnical engineering subject. Then you can see fluid mechanics subject, just 4 questions. And then environmental engineering question given a good number of reasonably 7 questions. And strength of materials and the structural analysis. In the SWAM subject, we had 2 questions. And the structural analysis, unfortunately, only 1 question. Totally put together, 3 questions were given. And you can see transportation engineering along the railway engineering given reasonably good weightage, 6 plus 2, 6 questions from the transportation, that is basically highway engineering, and the 2 questions from the railway engineering. Then hydrology and irrigation, you can see 1 plus totally we have 4 questions. And surveying, it is given good weightage here in this particular examination. Totally we had 8 questions. And the design part of this RCC and the steel structures, you can see 11 questions. But here I feel steel should have been given some more questions, but unfortunately it happens sometimes in examination. RCC was given almost 10 questions and steel was given, I think, only 1 question you can see there. It happens in examination sometimes. Okay, leave it. It's only related to competitive examination, nothing to worry about. The effect is equal on all the students, right? And building materials given very good weightage of 13 questions. That is something special. 13 questions from the building materials. And then construction project manage, CPM and then the estimation. You can see 3 questions totally. Aptitude and mathematics, 15 plus 6, very good weightage reasonably. So totally we had 95 questions. But if you see all the questions from this what you call paper, I can say along with my discussion with my colleague faculty members also, the paper standard is easy to moderate. Most of the questions are straightforward, easy questions only, except a few questions. So we may rate this question paper standard as something easy to moderate. I hope most of you might have done well. So I take this opportunity to wish you all good luck, those who took this examination. So let me discuss the solutions of geotechnical engineering subject first. Then we see other faculty members to come one after other to discuss other subjects. We begin this geotechnical engineering subject. One of the questions you can see, the desirable properties of soil as a highway material. Please be specific here. What is being said is here, desirable properties. It is not just properties. If it is properties means we may say strength, compressibility, something like. What is being asked here? The desirable properties which you may like to have there. You can see stability, instability, compressibility, incompressibility. So which one do you desire? We desire stability. We desire no settlement. No settlement means it should be incompressible. That's why the desirable properties include stability, Incompressibility means no settlements. And also permanency of strength. Strength should be there permanently, should not be lost with that time. Therefore, this is the best option among these, D. The next question, this is the minimum water content required to make the soil flow under the application of very small shearing force. This is one of the definition for the liquid limit. Minimum water content at which the soil can flow under the application of very small shearing, nothing but definition of liquid limit. Where is it? So this is the liquid limit. This is the answer. Then you can see this is the one question I see from this geotechnical engineering, which has got relatively somewhat lengthy calculation. You are given density index of the soil, that is sandy soil, 65%. We have to make some calculation here. So density index, nothing but the usual symbol what you give, ID. It is given as 65%. And then the maximum minimum dry densities. You know the usual symbols what to use. Gamma D maximum and then gamma D minimum. Gamma D maximum, it is given as 16.5. Of course, kilo per meter cube. And gamma D minimum 13.5 kilo per meter cube. And specific gravity also given as 2.65. The question here is, what is the in situ void ratio? You are asked to find in situ. Formula. For example, you see this. I want to find minimum void ratio. Minimum void ratio is corresponding to the maximum dry density. If density is maximum, we have the thorough compaction. The void ratio will be minimum. So formula will be like this. Gamma D max is equal to gamma W into G by 1 plus E minimum. Be careful here. To get gamma D maximum, E should be minimum. This is a basic formula. Gamma W value not given in this data, as you can see there. Because gamma W is not given, you can take the approximate value for easy calculation purpose. Here I take gamma W value as 10 kN per meter cube. For calculation purpose, I take 10 kilonewtons per meter cube. So when you substitute data there in this particular formula, 16.5, gamma W 10, specific gravity 2.65 upon 1 plus E minimum. So when you work out the value of E minimum, the E minimum value you will get nearly 0.6. Nearly 0.6. In a similar manner, you have to also calculate maximum void ratio. Maximum void ratio corresponds to the gamma D value minimum. The formula will be like this. If you take gamma D minimum, gamma W into G by 1 plus E minimum. When E is minimum, gamma D will be, because the inversely proportional, to get gamma D value minimum, E must be maximum. E must be maximum. So I take this maximum here. Gamma D void ratio inversely proportional. Inversely, they are inversely related to. So gamma D minimum is 13.5, gamma W 10, G value 2.65, 1 plus E max. So when you simplify this, you will get E max as, the E max value as 0.93 you get. 0.93. So the question is calculation of the E. You know E maximum, you know E minimum. Now you can go for the ID formula. ID is equal to E max minus E by E max minus E minimum. All the data is available here. ID is given 0.65. E maximum is already known, 0.93 minus E, 0.93. E minimum you got value as 0.6. 0.6. So when you solve this equation, you are going to get the E value as 0.72. 0.72 is the actual answer. This is the actual answer, 0.72. But when you see the options there, 0.72 is not there. Therefore, you have to go to the nearest option. Nearest option is 0.66. Therefore, A is the answer there. This is the only question that may take a little bit time, except that remaining all are easy and straightforward question as per this geotechnical subject is concerned. These are the calculations. Okay. Then we move to the next question. What is the ultimate load carrying capacity of friction pile? It's not a combined pile, it's not an end bearing pile. This is a friction pile. Diameter given, length given, clay soil. C is given, alpha is also given. So how to find the ultimate capacity of the friction pile? We have this formula, ultimate capacity of the skin friction. The formula is surface area. Surface area means pi d into length. Pi d perimeter into length, that gives surface area. Surface area into alpha into C. Alpha is addition factor, C is the cohesion. All the data is available there. When you substitute the data there, right, pi, diameter given 0.3, length is given how much? 10 meters. Alpha is given 0.8. So this is 0.8 and the C value given 40 kilopascals. So pi value you can take 3.14, 3.4 into 0.3 into 10. So when you work out, the value will come nearly 301 kilonewtons. You can see the option available there, option C. So this is the answer, ultimate skin friction capacity of this pile. The next question, liquid limit, positive limit of the fine grained soils given as a 45 and then 32% respectively. What is the type of soil as per the IS classification system? Here if you can see, liquid limit is given as 45. Since it is between 35 and 50, it must be intermediate compressible. It must be intermediate compressible. If you see the options there, intermediate compressible, intermediate. So answer must be between these two. How to decide the clay or silt? For that you require IP values, means plasticity index value. Let us see those values. IP of the soil you have to calculate. IP of soil is equal to liquid limit minus plastic limit. Liquid limit is 45, plastic limit is 32. 45 minus 32. How much? 8 plus 5, that is 13. You will get 13. Then you require IP of the A line there. IP of A line. Hope you know the formula. We have the formula like this, 0.73 into liquid limit minus 20. When you substitute the data there, 0.73, liquid limit is given 45 minus 20. So 25 into 0.73, it may come to be, right, I have the made calculation, it comes to be exactly around 18.23 IP of A line. So if you compare the IP of the soil and IP of the A line, IP of the soil is something less than the IP of A line. So if you plot the point on the plasticity chart, IP of the soil is going to fall below the A line. So this is the A line equation. Height of A line is 18.23. Or IP of soil is only 13. 13 is less. So IP of soil is going to plot below A line. Below A line means it is a silty soil. Silty means symbol is M. So intermediate compressible silty soil. So this is the answer. Intermediate compressible silty soil. So this is the solution for this question. Next is, when the water table is at the base of the footing, the water correction factors RW1, RW2. This is a straightforward question. You have to recall the basic formula as per the Terjagi for the calculation of the bearing capacity with the effect of water table. I may recall this equation something like this. Ultimate bearing capacity is equal to CNC plus gamma df NQ. Here comes the RW1, nothing but water table correction factor, plus 0.5 gamma B N gamma into RW2. What is said here? Water table is, where is it? At the base of the footing. At the base of the footing means something like this. If this is the footing, at the base of the footing, this is the position of water table. You may be knowing RW1 is for the depth effect. For this one, we have this RW1. RW2 is for the wedge portion which is present below the base of the footing. So for this soil, we use RW2 to take the effect of water table correction factor. So you can see here, only this wedge of the soil is under submergence. Because completely under submergence, RW2 value will be 0.5 because the entire wedge is under submergence. We have the maximum correction nothing but 0.5. What about the surcharge term RW1? It has no effect of water table. No effect means this correction factor is 1. So RW1 is 1, RW2 is 0.5. RW1 is 1, RW2 is 0.5. So therefore, this is the answer. This is the answer. Next is, for a rigid footing resting on a saturated clayey soil. Please be careful here. The footing is rigid, resting on the clayey soil. You are asked to answer regarding the contact pressure variation. You may recall the pressure distribution diagram. If this is rigid footing, resting on a clayey soil. So this is the rigid footing resting on clayey soil. If you draw the contact pressure distribution diagram, it will be something like this. So as you see in this diagram, minimum pressure is at the center and maximum is at the edges. So this is a diagram that shows what you call contact pressure. So let us see the options available. Contact pressure on the footing, maximum at the edges, yes, that is true, and minimum at the center, yes. Straight away, very first one. That's what you can see the diagram also. Maximum at the edges, minimum at the center. Maximum at the edges and minimum at the center. What about others? Yes. So this is the correct option based on this diagram. The next one is the Proctor's needle method in the field compaction. Remember, it's a field compaction. Useful to quickly measure thickness, no. Compact to effort, no. Bulk density, no. We may use to get what you call dry density, but not bulk density. Yes, you must be knowing that Proctor's needle is basically used to measure the what you call placement water content. It gives approximately the water content. water content. Therefore, the answer is D. Yeah. Settlement of a pile group placed in the sandy soil. If you compare settlement of a single pile, settlement of a group of pile on the sandy soil, you can see these have no relevance at all. Not exceeding 10 times settlement of single pile, not exceed, yes. If you see any standard textbook on the soil mechanics, any standard textbook, this point is given in the pile foundation, settlement of the pile groups, right? So what the literature says is, the settlement of the pile group in the case of a sandy soil, it cannot exceed 16 times the settlement of single pile. So this is the answer. So 16 times. It is given in most of the standard textbooks. Straight away this is the statement there. Not exceeding 16 times the settlement of single pile. Then, the quotient of uniformity Cu and the quotient of curvature Cc for a well-graded sand. Straightforward question. In the case of well-graded sand, quotient of uniformity should be more than 6. Quotient of curvature should be between 1 and 3. Let us see the options. Cu must be greater than 4. No. This is the statement, this is the what you call specification for the well-graded gravel. But in our case, the soil is a sandy soil. So Cu must be greater than 6, yes. And Cc must be between 1 and 3, yes. So this is the correct option. Remaining are irrelevant. Cu more than 6 and Cc must be between 1 and 3. B is the option B. Due to cohesion, the passive earth pressure on the retaining wall. Be careful, it's not active. What he said, passive pressure on the retaining wall. If you write the equation for the passive pressure, the formula is Kp sigma V plus a 2c into square root of Kp with the usual notations. In the case of active case, we come across here minus symbol. This being a passive case, we get a positive sign. As you see in this formula, because of this cohesion, the passive pressure is increasing. It is having a what you call a plus sign. Therefore, because of cohesion, passive pressure is increasing. Let us see options. Due to cohesion, the passive pressure increases. Suppose the question is active pressure. In the case of active, you have a minus sign, that you have to say decreases. In this case, it is passive. So because of passive, you have a plus sign, therefore increases. Option B is the answer there. Then, the total active thrust. Be careful here, it's not the active pressure. It is the thrust. Thrust means force. How do you get force in the case of retaining wall? If you take the area of the pressure diagram, that area diagram gives you what you call the thrust, nothing but the force. The total active thrust in a cohesive soil will become 0 at depth of tension crack, no. Because at a depth of tension crack, pressure becomes 0, but not the force. If you go to critical depth nothing but with the notations what you use HC. At a depth of critical depth, the algebraic sum of the negative and the positive diagram, the total area becomes 0. Therefore, the thrust means nothing but area of the diagram. The total algebraic sum of area becomes 0 at a depth of critical depth. That's why this is the answer, critical depth, nothing but HC. You may also call it as critical height. Critical height, nothing but critical depth only. The cohesive soil. Next is the bearing capacity factor NC to be taken for the estimating the load carrying capacity of the pile in a clayey soil. In the case of a clayey soils, we use the formula CNC to estimate the bearing capacity. Their NC value we take maximum. In the case of a clayey soils, the value we take as 9. A simple question. So this is the answer. 9 is the bearing capacity factor NC to be taken for the capacity of pile in the case of clayey soils. So that's all from this GT subject. So we had totally 13 questions. Out of 13, only 1 or 2 somewhat what you call you have to apply some mind there. Remaining are straightforward questions only, right? So I request my other colleague faculty members to come one by one and discuss their subjects in the order.
Yeah, good evening friends. Coming to the strength of material, we are having only 2 questions. Both questions are straight questions. There is no calculation part this time. Just to see the first question, this is from centroid concept. If the unit of rectangular moment of inertia is m to the power 4, what is the unit of polar moment of inertia? Straightforward question. So unit for the polar moment of inertia is asking, that is m to the power 4. Option B is correct. The straight question it is. The next question is, this is from the concept of simple stresses and strains. Comparison between material property and elongations are mentioned. Just read the question. The elongation ratio of 2 isotropic materials having the same dimensions and subjected to the same load, that elongation ratio is given as 2:4. Then what we required? The ratio of modulus of 2 isotropic materials. So axial deformation formula, once you recall, it is PL upon AU, we know it. As dimensions and load are same in both materials, so this is constant. Then observe the relation between del L and the corresponding E value, it is inversely proportional. So what we required? So we required E1 divided by E2. E1 divided by E2 equal to del L2 divided by del L1. Del L1 is to del L2, how much it is given? 2:4. Then it is automatically 4/2. So 4:2. E1 is to E2 equal to 4:2. 4:2 we are observing at number D. This is the correct option. These 2 questions only this time we are having from strength of material. Both are a very straight questions. So hope you did your examination very well. So I hand over this platform to my colleague Keshu Reddy sir.